I want to add this on at the end to, or somewhere in my rant that I just had about the Andromeda Galaxy paradox. And I just watched a video kind of explaining it again, just to make sure that I'm understanding things right. And, maybe this person that I watched their video on misunderstands it as well. But where this discrepancy is coming from is basically they say, oh, well, when the light eventually does reach them, it will reach them at the same time. It's just that they will think that it happened further in the past, comparatively. One will be like, oh, well, it happened this many years ago, compared to a person that will say, well, it happened this many years ago, right? And this comes from them saying, so, light is sent out, like the way they explained it in their videos is light is sent out to, towards two clocks, and the clock that is closer to the person moving is going to read like a certain time later than the one that's farther away, or something along those lines. And what the problem is they say like the light expands out, and as it expands out, these clocks are moving because in the jogger's reference frame they're not moving, but everything else is, right? So the misconception here that is coming from this is assuming that the light signal that is, interfering with these clocks is, they use radio, but I mean, same thing, I don't know. So the problem is that they're assuming that this signal is not also moving in the same, with the clocks and everything else. And I don't understand why it's assumed that it's not moving, because if they're both still, right? The argument is to the stationary observer, they're both still, right? And when the signal hits one compared to the other, it will, since they're both equally distant apart and nothing's moving, they will both be turned on at the same time. But if the signal is moving, the signal will stretch out, but as they move, the one that is, moving away from the signal is going to take longer to get that signal, and so it will have there'll be a different observation. And my problem with this is why doesn't the signal travel with everything else? We know that light is bent by gravity. We know that we know that, I don't understand. I just don't understand why the signal doesn't travel with everything else. If everything is moving except for the person that's stationed, like the jogger is. If everything's moving around the jogger, why doesn't the light also move with the clocks? And I don't understand. I don't understand. I don't understand. This scenario, this explanation is wrong. It doesn't make sense. When you're in a train and you shine the light towards the front and towards the back, right? It makes sense that it should hit from an outside perspective, it does seem to make sense that the light will hit the back of the train before the front of the train. But this is different. This is different. I don't know how else to explain it. because when you turn the light on in the train, the entire train is moving away, right? And so the system in which you're observing, it's not that the system in which you're observing is all of it is moving and you're stationary. And so when you're looking at it, to you, it makes sense that the light that is traveling towards the part that's moving away should, take longer to get there because it's traveling a farther distance than the side which is, moving towards it. Right? So in that scenario, it makes sense that the front of the train should take longer to get to the front of the train than the back. Because when the light is sent out, it is traveling at the same speed, except the distances between these 2 points is changing. And so that is why, from an outside perspective, it would seem like it should take longer. But when we're looking at this scenario, the problem is that the 2 objects, the distance between these 2 objects is not changing. There is no difference in distance between these 2 objects, because to you it is moving closer to you, yes. But the distance between where the source was emitted and where, this clock is, imagine there's 2 walls, just because like the light being emitted between these 2 walls, there's no change in distance between these 2 walls. The walls themselves are not moving in the stationary reference frame. And if they are moving, they're all moving together and at a constant speed. And so it would be like when you're on the I feel like I'm fumbling here on this explanation, but I promise you that it's wrong and this makes sense, because pretty much what's happening here is when you're on the train, the light appears in your perspective to hit both sides at the same time. But when you're off the train, it doesn't. Because you're stationary and the train itself is moving. And then in the other frame, everything is in constant motion. So it's as if everything is still. And that's why it works like that. But when you are the one who's moving, everything else seems to be moving, yes, but it's moving at a constant rate. And what's happening is it's almost as if you're on the train, like because the wall, it's not, the walls aren't moving closer to where the light source was sent out, right? Because in the train reference frame, the light is moving out from where it originated at a constant speed, but the walls are not staying still. They are moving towards, they're moving in one direction. So as this light is coming out, this wall is coming towards it, and this wall is moving away. That is why it appears that it hits here before it hits over there. But to a person that's on the train, the walls are standing still. So it hits them both at the same time. But in this next reference frame, when we're talking about this Andromeda galaxy, you have you know, the light goes off and you're running, right? The walls themselves are as if they're the walls of the train. You know, the train is moving towards you, but when you're looking at it, it doesn't look like the light hits the back wall before the front wall, because the walls themselves don't move. The walls themselves are not moving closer and farther away from the source. They are staying in the same, they are moving towards you, but they're all moving towards you together. So the same rules don't apply. The difference between these two frames is that the source originates at one point, and that point stays where it was as the light moves out. But when you're just running towards it, it doesn't work like that. I don't know if I'm really explaining this. This was a fumble. But I'm right. It seems like they should be the same. And that's why I feel like I'm not getting it across correctly. But these scenarios are not the same thing. Because you are moving towards the light, but the light travels at a constant speed. So it is not hitting walls differently, because its reference frame is not changing, because the expansion of the light is getting carried I'm going to try again.